Our objectives are to apply scientific knowledge and applications obtained from the CNC technology topic, to generate machine parts using a program, to create a CNC programming coding for the program chosen and simulate according to the design, to understand and recognize basic tooling in the turning process before doing the program, capable to write coding and also modify a program, and can also create a coding based on what is learned and can solve problems. Uses of CNC lathe machine. A CNC lathe machine is typically used to perform and make exact rounds form with both outer and inner diameter. Depending on the needs of various industries, this machine tool could machine practically any type of structure. Live tools that can function in many axes are usually included in modern CNC. There are 6 types of CNC lathe machine. The first one is standard 2-axis, which take material from the outside of the component with outer diameter tooling and remove material from the center of the boring bar holders. Next is 3-axis with milling, which enables the operator to perform typical lathe work while also milling and drilling the piece and employing high-speed live tool, effectively combining 2 machines into one. Multi-axis is a multi-spindle or dual turret, which have 2 spindles and 2 turrets. A chucking CNC lathe is one that does not have a tailstock and is typically used for minor second operation turning. Next is flatbed CNC lathe, which has a detachable gap for higher turning diameters. Lastly is a big bore or oil-filled lathe, which is a lathe with larger bore size that is typically 6 inch or larger. Paper mills, shipbuilding and repair, textile and energy application all use this type of lathe.
Methodology. We choose the raw material from the laboratory. Before that, we have to create the 3D modeling and 3D drawing from sewing software for our screwdriver holder, and we create also a coding using Simultrain software and run the simulation. The Simultrain software help us to estimate time for operation, and we also can detect error of operation earlier. Then we transfer the coding into CNC machine using a flash drive, and we have to set up the coding according to the CNC machine regulation, because of some have no tool depend on the coding. Thank you.
So in this simulation, first of all, we are using basic header for the turning process, which is G90, G95, G80, G71, G54 and G64. Next, we select the cutting tools for the roughing process. Next, we are using the G00 for the rapid traverse, G01 for the linear interpolation, and G02 for the circular interpolation. We also set the feed rate to 0.1, and to stop the program, we set the coding to M30. This is the final result for the coding from the Simultrain software.
Numeric software is a tool to create a complete coding for our mini project, that is a screwdriver holder. What we get from lab activity is we get to know that CNC machine is very friendly user because it very easy to use once we understand the coding. By using the contour method for the curve at the product, it is very helping us to run the machine smoothly. Our product take about 11 minutes and 35 seconds to get the workpiece done. If the machine operate at 100%, but due to our lab, we just use a maximum of 70%. In the conclusion, we can complete the task given, and from this project, we understand the main point of this project on learning about CNC machine. We also managed to use and operate well software design from CNC machine. We applied the coding that we had learned on this project. Mostly, we are using G code and M code, and from that team can do simulation based on the coding and drawing. The simulation help us identify the coding error and the tool part. On the first try, we had many mistakes on coordinate, toolpath and spindle speed. The toolpath is important to avoid damage to the workpiece and machine tool. We decide to use the contour command, and in the end, we succeed to complete the task and the project. Besides, we made the real product using CNC turning machine based on 3D drawing.